morning, everyone. In my short presentation today, I will introduce what they are doing at NVIDIA to advance the quantum technology and empower the quantum ecosystem. At NVIDIA, we are not building any qubit, but we are building an accelerated quantum supercomputer. So this is an AI supercomputer that's going to be connected with a quantum hardware, and that's going to be useful for all hybrid application using GPU and QPU. Also, in addition to this quantum supercomputer, we are building a software stack that can be integrated into this quantum supercomputer, because there are going to be several quantum modalities, and we don't know which one will come first, and also what if there are going to be maybe some of them going to be useful for certain application, other will be for other application. So it's very important to have a software that is hardware agnostic, and we are building software to be hardware agnostic. And that's what I will go through in next slide. We are building the NVIDIA quantum platform, and it starts with CUDA-Q. CUDA-Q is a quantum classical, hybrid quantum classical programming model and compilation platform. It's a hardware agnostic. So here you can see all these logos are the quantum hardware that are can be accessed, available in the CUDA-Q backend, including the Amazon Braket, which is a cloud service that enables access for multiple quantum hardware. CUDA-Q is CUDA-like. It's a kernel-based programming model, and it allows tight integration with classical parallel programming as well. Because quantum hardware today is very noisy, and not all of us has access to quantum hardware. So we also see simulation as a very important component for the quantum computing workflow. And at NVIDIA, we're also building the quantum simulation library. So this is a GPU accelerated state vector and tensor network, and that's enable user to run their quantum circuit simulation to test it, for example, before running it on quantum hardware. But also it built to help scalability, so user can use the quantum to test their algorithm at a scale that is not accessible today by quantum hardware. In addition to state vector and tensor network, we are also enabled the quantum dynamic workflow. So there is now the GPU accelerated density matrix to enable simulation of the device to help design the quantum hardware. And here on the right, also you can see all the different platforms that has now integrated the quantum in the back end to enable simulation. At the very top, also here in top of quantum and CUDA-Q, we are building libraries to support user with the most important things they want to do with CUDA-Q. And we have two now libraries: quantum CUDA-Q with quantum error correction, and CUDA-Q solvers that is for hybrid quantum classical algorithm. At the very low level, we are building DGX quantum in collaboration with our partner Quantum Machines to enable a low latency interconnection between the QPU and the GPU. And so at NVIDIA, we are building the whole stack, and we welcome everyone to take the part that is more relevant to them, and also leave the rest. So with the quantum supercomputer, user will be able to run a very useful quantum applications, taking advantage of the quantum hardware and AI supercomputer. With quantum simulation library in CUDA-Q and AI supercomputer, user can start to test and develop their algorithm, and also run simulation as a device, run simulation for the device to design quantum hardware. And we are at NVIDIA, we are collaborating with everyone in the quantum ecosystem. And our mission here is to empower the quantum ecosystem. And we have been enabling that, and enabling the most important research, some of the most important research happening these days. And we are proud to help our partner leverage and develop their quantum technology. With that, I thank you.